This is a math lesson for Ellie. She has a question about dosage mixture math. And so I'm going to start by backing way up to use kindergarten math as an example. Let's sort of see an outline of what we will do with something we know very well. And then we'll go into the actual dosage mixture math. So when I want to teach addition, maybe something as simple as 3 plus 4. First, I will go forward and I will say if I have 3 of something and combine it with 4 more of something, what is 3 plus 4? And the kindergartner can put it all together and count to 7 and say, 3 plus 4 is 7. So going in that direction, adding two amounts that we start out knowing is simplest. Then, if I wanted to be more complicated and check if the kindergartner really understood things, I could leave out the number in the middle. I could say 2 plus something is 5. What's the answer? And the student could say, well, these two go with those, so there's 3 others, so this number in the middle has to be 3. And then I could know they really understood how addition works. So we will do the same thing with the dosage math. We're going to start by combining the two things in the direction that we sort of make sense. And then we will say what happens if we're missing some information about what we're combining, but we do know the end result. Okay, so dosage math is only confusing because we are adding two things at once. So let's imagine we have two things. The example in your textbook that we looked at had one of them being a drops and another being an ointment. So I'm writing at the top drops and ointment just to keep track of that. Can I make my focus a little better for the drops page without destroying the ointment? Maybe. Okay. And so I have something to talk about. What are these measured in? That has to be the same. Are we measuring this in grams or milliliters or whatever? So let's just say for now that they're grams. And I'm going to use different tools. Rather than just little glass beads, we're having two things we're talking about at once. One is how many drops we have, maybe 2. How much ointment we have, maybe 3 grams. I slide that over. And then in each of those grams, how much of the actual medicine is there? So let's say that on our 10 by 10 hundreds cube, see if I can get that in focus, sort of, we have 2 out of 100, 2% on the drops. The drops have a 2%, that's medicine. And the ointment, let's say the ointment is 7%. Okay, just in case someone really cares, we can line all of these up nice. 7 out of 10. Now it looks pretty. Okay. So my question in the textbook, of course, isn't going to have cute blocks. It's going to say you have drops, 2 grams of drops. Each is 2% medicine. And you have some ointment, 3 grams of ointment. Each is 7% medicine. When you mix this all together, what's the percentage and the amount? So you can see we're adding two things at once. Easy to see, different shapes, different colors. So if I mix this all together, blah, 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 then all I have to do is smash it, just like we did with the glass cubes. Before I do that, I want to write this down on my paper so that it looks like what you're doing in your homework. So We have the drops, and we have the ointment. And I know you can't see what I'm writing, but we'll fix that in just a moment. Drops and ointment. And the drops, we have 2% on each of 2. And we're adding that to the ointment, which has 7% on each of 3. Focus. Where is focus? There. Okay, now it's easy. We just smash everything together. Blah, 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 blah. When we do enough mixing, then we want to kind of even this out. So how can we even this out? Is this actually going to work out so easy? So it's more than that. Let's keep mixing. Ah, there we go. So each of these grams now has 5 bits of medicine. And we have 5 grams of the mixture, and each of them has 5 bits of medicine on it. So on my paper, I can write 5% on each of 5. And as makes sense, the amount of grams we have, we just add. 2 plus 3 is 5. Right? We had so much stuff, the big blue things, and we mixed it together. But the yellow doesn't just add 2% and 7%. We are not adding them and making 9. Rather, there's sort of a balancing out that's happening. The ones that started with very few got more. The ones that started with 7 got less as everything balanced out. If I didn't have the blocks to rearrange, how would I do this on the paper? I don't know the answer yet. I would have to say 2% on each of 2. I could change my percents into decimals, 0.02, 0.07, but I don't need to do that. I can just live in percent world as long as I'm consistent about that. So 2% on each of 2. We're back to this part. Right? So that's going to be 2 times 2, 2 copies of 2. And as we did working together, I can draw parentheses around this. I don't need to draw parentheses because the multiplication will happen before the addition, but I can. Makes my eyes happier. And here I have 7 on each of 3. So that's just going to be 7 times 3. And I know that there's going to be 5 total. So I'm going to have something, some amount, times 5. Because I can't see immediately what the percent will be. Okay, 2 times 2 is 4. 7 times 3 is 21. And y times 5, let's just write that as 5y. 4 and 21 is 25. Something is stuck onto y with times 5, so get rid of it with divide 5. If I do it to one side, I have to do it to the other to be fair. And I get the answer of 5, the same that we saw when we physically did this with the cubes. So that was the easy going forward type of stuff. Now let's see if we really understand it by doing one where we're missing some information in the middle. In this problem, let's change it up a little. What should we do? Why don't we have, let's make these fairly big. How about 5, 10, 11, 5, 10, 11. So now our drops are at 11%. And I'm not sure what's on the ointment, but I know that my goal is going to be an 8% mixture once I've mixed everything up. So there's something here, but I'm not sure what it is. Whatever is on these three is going to be the same. So this is my mystery amount. I have some amount of yellow blocks, and I don't know what it is. This is like a container of yellow blocks, a clump of yellow blocks. How would I figure this one out? Well, let's smash everything together and mix it. If I want there to be 8 on each of these 5, 8 times 5 is 40. So I'm going to want a total of 40 yellow blocks. So I smash things together, I mix everything up. I had 2 11s, so that's 22. So I have 3 other groups, and I want to get to 40. So if I have 22, how much more do I need to get to 40? 40 minus 22 is 18. So these together are 18. Each of them then is going to want to be a third of 18. So each of them can be 6. Now I figured out what those represented. Okay, let's do this on the paper. Oh, first let's check that we got it right. Does this actually make 8 on each? Four and 4, 4 and 4, 4 and 4. Yes, it actually does make 8 on each. We did this right. Okay, now let's go back and do this on paper. I'm going to reset. So if that's 8, 9, 10, 11, 9, 10, 11, unknown amounts. So again, I'm going to have drops and ointment, and I want to label things because it will be easy to make mistakes. Maybe I should even put mixture on the other side of the equal sign. Keep track of what's happening. Okay, I have my drops, my ointment, my mixture, and I'm going to be adding up 11% on each of 2. Plus some amount I don't know, so I'll use a letter like Y. And this time they told me what the goal is. The goal is 8%. And I can see that with 2 and 3, I'm going to have 5 grams total after I mix it. So my situation is 11% on each of 2, plus some unknown amount, y% on each of 3, is 8% on each of, well, how many? 5, because of the 2 plus 3. Now I'll translate that more to look like algebra. So I have 11 on each of 2 is times 2, y times 3, and 8 times 5. Again, I don't need to turn this into decimal format of 0.11 and 0.08. I'll just stay in kind of percent land and know that that's what I'm doing. Okay, 11 times 2 is 22. Y times 3 we'll call 3y. 8 times 5 is 40. We talked about shoes and socks. Mathematicians have this shoes and socks analogy where if I want to get dressed in the morning, I have to put my socks on before my shoes. Doesn't work the other way. And similarly, when I want to get undressed, I have to take my shoes off first. There's just no way to take my socks off first. So I have things stuck on y. The thing that's stuck on y most tightly is the multiplying. That's like the socks. So I'll deal with that last. First, I'm going to deal with this 22 and 40. There's something stuck onto y with a plus 22. Let's get rid of that. So take away 22 on both sides. The opposite of plus 22 is minus 22. So now we have 3y is 18. That's the shoes step. Now the thing more tightly stuck onto y is the times 3. So we'll undo that with a divided by 3. To be fair, I have to do it to both sides. And we get the y equals 6. That's the socks step. And then we're done, right? All of these we should label better. This is grams or whatever it is they actually gave us. But there's your generic system for doing mixtures, realizing that you are adding two things at once. You're adding the grams or milliliters or whatever, these big kind of containers of medicine, and then you're adding the small amount, the percentages of each gram, the percent of each milliliter, however it is in your problem. And now you know how to add two things at once.